Alright, so today we're going to talk about inverse functions. Okay, so all of our trig functions are going to have inverse functions. So sine, cosine, tangent, cotangent, cosecant, and secant. But the nice thing is, guys, we're not going to graph them. We're just going to use the inverses to help us solve. So inverses, what we use them for is to solve for the angle. Okay, so first of all, let's think about our graphs, just our normal graph, and what we know about inverses. So when we talked about inverses back in the last chapter, we said that in order for a function to have an inverse, it has to cross our horizontal line test. Okay, so if we think of our graph of sine, cosine, tangent, any of them, if I were to graph those, so if I have, say I'm going to graph sine real quick, so starts at the origin, goes like that. Okay, so here's my sine graph. Does this pass a horizontal line test? No, because if I draw a horizontal line, don't I hit a bunch of different times? Like, we have all these points. Okay, what about, do you think a tangent graph, will that pass a horizontal line test?
Yes.
Well, let's think about it. Okay, so tangent, we go from negative pi over 2 to pi over 2, and I have these asymptotes.
I mean, I guess that one depends on how many.
Then doesn't it keep going? I have all these tangent graphs.
So if that's the case, nothing passes the one-to-one.
So that's not going to pass. It would pass a vertical line test, yeah. But, so it makes it a function. But, so that one's not going to pass a horizontal line test. What do you guys think about secant? If we think about like our u's, is that one going to pass?
No.
No. So all of our graphs, in order to have an inverse, what we need to do is we need to restrict their domain so that they are going to actually pass the horizontal line test so that we can use an inverse. And in terms of like what that means, it's like going around the circle just once, like using the unit circle once instead of going around it multiple times. So we only go around the unit circle once. Those are the angles we'll be looking at. Okay? So for our sine function, where we're going to restrict it, so it says to have an inverse, you have to restrict our domain of our graph. So for sine, we're going to use from negative pi over 2 to pi over 2. It's just going to be this chunk right here. So all of our angles, so like when we're looking at our unit circle, if I think about my unit circle, I know that on my unit circle, so if I have a circle, this up here is pi over 2, and then this down here would be the negative pi over 2, because if I was going in the opposite direction. So all of my sine values, so when it says find inverse sine, I'm looking at angles that are going to be in here. So I won't even use the other side of the circle. Okay, so by limiting our domain, it tells us like where we're looking on the circle to find our answers to solve things. Okay, so we're limiting our graph, we're restricting our domain from negative pi over 2 to pi over 2, and then that's where all of our answers are going to come from. Okay? Okay, so just a little bit about the actual inverse sine graph. So, since we restricted our sine domain from negative pi over 2 to pi over 2, if I were to take the inverse of this, we talked about with inverses, graphically what's going on is you're going to be reflecting over the line y equals x. Okay, so the inverse sine graph is going to look like this right here, because if I were to take my sine graph and I'm going from negative pi over 2 to pi over 2, that's these points, and usually sine looks like that. If I reflect this over my line y equals x, these chunks just get flipped, so it'd be like this, and then this one would be like this, which is exactly what that graph looks like. Okay, so this is my graph of inverse sine. You guys with me?
Nope,
Nope, what are you confused on?
I'm not gonna, just keep going.
Just keep going, okay. So when we're talking about inverses, you can see it written two different ways. It can say arc sine or inverse sine with the little -1. Those are the exact same thing. Okay, so you'll just see it written two different ways, but when we see that, we know we're dealing with the same thing. Okay, either one is the inverse. Okay, couple more things with our graph. Looking at our inverse sine graph, sorry, this should say sine. Looking at our inverse sine graph, it's going to be increasing over the entire interval. So our graph is going up, it's increasing, it has positive slope the entire time. The domain of this graph is from -1 to 1. Our range is from -π/2 to π/2. And these make sense because remember when we were talking about inverses, we said like your x and your y flip, like your domain and your ranges like are opposite. So for a normal sine graph, for sine, our domain is usually, if we were to limit our sine graph from -π/2 to π/2, and our range was from -1 to 1. So for our normal sine graph, so our inverse, we always just flip things. So for our inverse sine graph, now our domain is -1 to 1, which is what our range was before. And then our range of our inverse is our domain of our original. Do you guys remember talking about that? Yeah, okay, yep, so that's how those all work out. So your domain and your range of your original sine graph are just flipped for your inverse, okay? And then this graph right here, it is 1 to 1, it passes that horizontal line test. I could draw any horizontal line, and it's like, this is an inverse. This could have an inverse. We could have an inverse of an inverse because it passes our horizontal line test. We wouldn't do anything like that. And this graph is just this one piece. It's not like we have multiple of them like we do with tangent or cotangent. Okay? Are we feeling okay? We're not actually ever going to graph these. I'm just showing you what the graph looks like because it helps us with the solving. We're not graphing this section.
That's my favorite.
Graphing's your favorite?
No, not graphing is my favorite.
I would guess we graph the next section.
No, we're not actually ever gonna
There's a
graph
lot
these.
of subsets.
Okay guys, so cosine, if I have my original cosine graph, so not my inverse one, but my original one, I also have to restrict my domain of that. So we're gonna restrict our domain from 0 to pi for that graph. So then once I restrict it from 0 to pi, I can go ahead and solve, like graph an inverse or like use that to find my inverses. And so because if I think about my unit circle, so all of my values are gonna be in between 0 and pi. So when I'm using cosine, like inverse cosine, all of my angles I'm looking for are gonna be in here, between 0 and pi. Okay, so for sine, they're in between the -π/2 and pi/2, but for cosine, they're in between 0 and pi. Okay, so this kind of helps you know where to look on your circle. Okay, again, it can be written either way, so we can have arc cosine or inverse cosine, but same thing. And then some properties to consider. Our graph of inverse cosine is decreasing over the whole interval. The domain is -1 to 1. Range is 0 to pi, and those make sense because they're opposite of the original. And then it is 1 to 1 on that whole interval, so we could have an inverse of that if we wanted. use what I just said. So grab out your unit circle. And you'll probably want your calculator today too, because they might not all be on the unit circle. So grab both of those.
Hey, Brady, want to go on 5?
Okay, so the first one, it says arc sine of -1/2. So what this means is I'm looking for the angle where sine is -1/2, okay? But if you look at your circle, there might be 2 spots that our sine is -1/2. So I need to make sure I'm in the correct domain. So should I be looking from -π/2 to π/2 or 0 to pi? Yeah, so I'm looking in quadrant 1 and quadrant 4. Okay, so I'm looking over on this half. So is there an angle that I see on my unit circle where my sine value is -1/2? What is it? 330. What's it in radians? 11 pi/6. Yeah. Yeah. Yep. So we can say that that's 11 pi/6. Okay? Or you could also use negatives, because remember, like, this is -π/2. So 11 pi/6 is the same thing as -π/6. Same angle, doesn't matter, but if you're checking your answers in the back of the book, it might write it as -π/6. Just like a smaller number. Okay, because those are the same exact angle. So this 11 pi/6, that's going this way around the circle, but -π/6 is just going backwards. Okay? So yeah, so that's where my sine value is -1/2. Is everyone good? Okay, let's do the next one. So this one, it says the inverse sine, same thing, it's the same notation, or different notation, but means the same thing. So the inverse sine of the square root of 3/2. So I want to figure out what angle has sine at the square root of 3/2. -π/3? Positive, right? Like this one up here, π/3? Yeah, it should be π/3. Were you looking at, did you look at negative square root of 3/2, Madison? Yeah, it's positive. Because this is, the -1 is all, yeah. Okay, so we should have just π/3. Is everyone okay with that? Okay, what about this other one? The inverse sine of 2. Is that on my circle? No. So let's think about these numbers wise. Actually, type this in your calculator. So go ahead, turn your calculator on. If you hit second and then sine, that'll give you the inverse sine. So type in second, sine, and then 2. And I would make sure you're in radians mode. So you're giving you an error?
Error.
Yeah. Okay, so if we think about this logically, so what's the number that -π/2 is? Like, what's that equal to? If you type that in your calculator.
Say that again.
Type in -π/2. What number does that give you? Yeah, like -1.57. Yeah. So then what's π/2? 1.57. Is 2 in between -1.57 and 1.57? No, because 2 would be like over here. It'd be past 1.57. So that number is not in our domain, so that's why it's an error. Because we're only looking from here to here. We only get to use this part of the circle. Okay?
So what's the answer?
So nothing.
Undefined.
Just
I
undefined.
like those answers.
Yeah, so this one would be undefined. Yep, so if you get an error in your calculator, you just know that that number is outside of your domain. So,
So the whole circle is 6.2.
yeah, so the whole circle would be 6.28. So we can figure out like where the numbers are just by using like pi over, we know pi is 3.14, we can figure out all those numbers. Okay. Okay, so this tells us we've already been using sine and cosine, where to look on our circle for those. But so sine, cosecant, and tangent are gonna be in the negative pi over 2 to pi over 2, okay? And then cosine, secant, and cotangent are gonna be in the 0 to pi. Okay, so this helps us figure out where we're looking on our circle. So you first look at what you're given, if it's sine or cosine or secant or whatever it is, and then because there's always two values on our circle, we need to know like which one we're looking at, okay? So if it helps you, like sine and cosecant, those get paired together, we know that, so they're both in the same domain. But then tangent's also in that one. And then cosine and secant are paired together, so they're both in the same domain, and then cotangents with them. Okay, so I don't have really a trick for how to remember those, but yeah. Yep, so, yeah, so cosine, secant, and cotangent, these ones are in quadrants 1 and 2, because they're up here on the top half of your circle. And then sine, cosecant, and tangent are in quadrants 1 and 4, because they're on like the side of the circle. Okay. Okay, let's go ahead, let's do some more. So I have arc cosine of square root of 2 over 2. So I'm looking at where what angle gives me a cosine value of the square root of 2 over 2? Pi over 4? Yeah. Okay. Arc cosine of square root of 2 over 2. And Shannon said pi over 4. Yep, because if I were to look on my circle at pi over 4, right here in the middle, I have a cosine value of square root of 2 over 2. And that's in my correct domain, okay? Because I know that my cosine is in quadrants 1 and 2. It's in quadrant 1, so that works for us. So it's going to be pi over 4. Okay? How are you guys doing? Like way better than the last section?
Yep.
Okay. Okay, let's try this next one. So the inverse cosine of 1, or of, is it negative? Oh, negative 1, sorry. So where do I think my cosine value is negative 1? Pi. Yep, so it's over at pi. Is that in my domain?
Yeah.
Yeah, so that's fine. Yep. Because I include the 0 and I include the pi. So I can't go past pi, but I can include the pi. Okay? So because the cosine of pi is negative 1. So you see how they're all the same? So the inverse cosine of negative 1 is pi. All right, what about arctangent of 0?
0.
Is there a button on here that does arc?
Inverse. So
Oh, it's all the same.
It's all the same.
Isn't it just 0? Because if arctangent of 0 is 0. No, wait, never mind.
Okay, so you're saying 0, Madison. So we know that tangent is our sine over cosine, right? So we're looking at the angle where my sine over cosine is going to be 0. So if we look at 0, what's my cosine and my sine at 0?
0, 0. 1, 0.
1, 0. So if I do sine over cosine, what would it be? 0 over 1, right? Because my sine's 0, my cosine's 1. 0 over 1 is just 0. So my tangent value at 0 is 0. So my arctangent, or my inverse tangent of 0 is the angle 0. Are we okay? Ready? Good? Okay. All right, the last one, we have the inverse tangent of negative 1. So I'm looking for what angle is going to give me a tangent value of negative 1. So I need to think what sine over cosine is negative 1. Like what angle is sine over cosine negative 1? What do we think about that?
3 pi over 2.
3 pi over 2?
I don't know, that was just a guess.
This one down here?
Yeah.
Is that, okay. So 3 pi over 2.
No, that's not.
You don't like that guess anymore? Okay. Pi, okay? So,
Well, you can't do that because if
That's just a prank.
tangents and this don't.
yep, so tangent's these ones, so it can only be on this side. Blake, what do you think?
Negative pi over 4.
Negative pi over 4? Yeah, let's try that. So negative pi over 4 down here. Negative pi over 4, what's my sine and cosine there, Blake?
Negative square root 2 over 2 and positive square root 2 over 2.
Yeah, my sine is negative, or, so my cosine is square root of 2 over 2. And my sine is negative square root of 2 over 2. Okay, so if I look at my unit circle, so at negative pi over 4, so this angle down here, my cosine is square root of 2 over 2, and my sine is negative square root of 2 over 2. So then if I do sine over cosine, I'd have negative square root of 2 over 2 over square root of 2 over 2, which what would that simplify to? Yeah, I could multiply by my reciprocal, so I could take this, flip it, and I'd have 2 over square root of 2. So then I have negative square root of 2 times 2 over square root of 2 times 2, which all that's just going to be negative 1, right? Yeah, so this is going to be negative 1. Okay, so here we are at negative pi over 4. We have a tangent value of negative 1, so my answer would be negative pi over 4. Because at negative pi over 4, so at the angle negative pi over 4, I have a tangent value of negative 1. I know the tangent ones are harder because they're not all in the circle, but we can figure them out just by doing like sine and cosine. Or you guys have already taken your quiz, so you can write all those tangent values on your circle because you get to use that circle now forever.
You
So-
like write on it, like numbers, but.
Yeah.
You can just say cosine and then sine, so like that, so.
Yeah, so if you want to go through and write all your tangent values on there, you could figure them out once, so you don't have to figure them out every time. And write those next to it. Okay? Okay. So let's go ahead, let's practice in our calculator. So if it says arctangent of negative 8.45, first of all, make sure you're in radians. So if you're not in radians, go to radians. Then arctangent is the same thing as inverse tangent. So go ahead and type second and then the tangent button. And then type in negative 8.45.
Can you say it?
Yeah, what do we get?
Negative 1.45.
Was everyone able to get negative 1.45? Okay. What about the next one? What about inverse cosine of 2? That one's an error, right? Because if we think cosine, that's not in our domain. So that one we would just say it's undefined. All right, what about something like secant? Do I have a button for secant on my calculator?
No. One over
Yeah.
sine.
Yeah, I think you just do 1 over the.
Oh, would you do the, yeah.
Yeah, I do 1 over cosine. So the way that I want to type this in, so you're gonna take inverse cosine of 1 over, because this is the value. Or you could just like flip it. So you could either type 1 over 2 square root of 3 over 3, but that gets kind of messy. But we know that secant is just the opposite of cosine. So I could type in the inverse cosine of, if I flip that, I'd have 3 over 2 square root of 3. And I know that that's going to be, because cosine and secant, we just flip them. It's giving you an error.
Yeah, I have it.
I got 0.52. Yeah.
And the last one, where does the 1 come from?
Oh.
Oh, you just flip it and leave the 1 out?
Yeah. So like these are the same thing, you guys. So we know that like secant is the same thing as 1 over cosine. So take 1 over my cosine value, I could type it in like this, or 1 over cosine, it's the same, you just flip the numbers. So we would just flip these, so we can type in inverse cosine.
Why?
You gotta put parentheses.
Yeah, so make sure you do inverse cosine, and then type 3 divided by an extra set of parentheses, 2 square root of 3, extra parenthesis, and then enter. So you should have parentheses around 2 square root of 3 and around the whole angle. Is everyone able to get it then?
Yeah.
Yes. Do you get it, Alex? Okay, so instead of 1 over inverse cosine, we just need inverse cosine. Yeah, because that 1 is with the angle. So yeah, so the reason that it's not 1 over the inverse cosine is because it's the inverse of the angle, not the inverse of like cosine. Okay, so it's like the angle needs to be the inverse, so that's why it's 1 over the angle. Okay? So yeah, so for typing these in, you're ever only gonna put sine, cosine, or tangent with like the inverses. You won't put 1 over that inverse. It'll be like the inverse 1 over the angle. Okay, let's try this last one. So if we have cotangent, I know I can't type that in my calculator, so what would I use instead? Inverse tangent. Yeah, if I use inverse tangent, and then what could I type in?
21 over 2 square root of 21.
Yeah, because I can just flip it, because I know that tangent and cotangent, we can flip them and they're the same. So I type inverse tangent of 21 over 2 square root of 21. And make sure you use some parentheses. And then Carter, what do you get for that one?
What is it?
Oh, thought you were raising your hand for me.
No, it's trying to.
Oh.
It's not charged.
So we type inverse tangent of 21 divided by 2 square root of 21. What'd you get, Alex?
1.16.
Yeah, 1.16.
What time is it?
Okay. All right, you guys, we will stop there. I think we just have like 3 slides left tomorrow to finish it up, but they're not too bad. So we'll finish these tomorrow, and then you guys will have some work time. Can you stop that for me?
Do you want me to?
Yeah, go ahead.